Hi and welcome to my video on integration by recognition, or it could be called integration by inspection. You'll see it with a couple of different names. Anyway, what we're going to do is learn how to integrate functions like this one here, where actually it looks like it could be a chain rule product rule type question. So it's just slightly harder than what you've dealt with before. Now, unless you're doing specialist maths, there's not going to be anything beyond what I show you today that you need to be able to do. And a lot of this integration by recognition or inspection is going to come with a first derive this kind of idea. So let's run with the first derive this question first and see where that leads to in terms of doing this integration. So I'm going to derive this function. Now hopefully you can see it is a chain rule function, so therefore when I derive it I'll be dealing with that chain rule process. So dydx in this case, or y dash depending on your notation, well cos goes to negative sign. So when we derive that, we get cos goes to negative sign, the inside component stays exactly the same, we don't change that. But we do need to multiply by the derivative of the inside function. So we multiply by, and this is sort of the long working, ddx of x squared. Now it's not quite the full chain rule working, but this is a little bit longer. Of course, ddx of x squared is 2x, so we get negative 2x sine of x squared. So then the question comes, how do we integrate 2x sine x squared with respect to x? Now this is quite hard, and you've got to be careful here because there's no product rule, chain rule approach to integration. It doesn't really work like that. What we have to recognise is that this is actually the result of this differentiation. Differentiation takes us one way, integration takes us back. So if integration takes us back, then this will take us back to our original function. Although not quite, so we have to be a little bit careful here. So what I'm going to do is I'm going to show you how I might set this out using this idea. I've done this original derivative, so I'm going to just change this slightly and say, well this is equal to negative, the integral of negative 2x sine x squared dx. My goal here, and my goal will always be the same, is to get this thing to be equal to the derivative result that I got earlier. So that's my derivative result. I want the inside thing to be equal to that, which means I'll probably end up with some extra stuff on the outside, which is fine. I've just got two negatives and that makes it a positive. When I integrate this, I'll now get negative cos of x squared. So this leads to that. And therefore this integral is that. But I do have to remember, we are integrating of course, it could be a plus c. So I always add on a plus c. So there's a first example of integration by recognition. I'm just going to clean the board now and we'll do a second example. Okay, so welcome back, and here's our second example. Again, it's set up as a derive this, therefore integrate that type question. So let's run through it quickly. Y equals e to the 7x squared. If I want to derive this, I get dy dx is equal to e to the 7x squared. Remember, if we derive an exponential base e, it just derives to itself. But we have to multiply by the derivative of the inside function, ddx of 7x squared. And so this becomes 14x e to the 7x squared. So there we go. We've derived this first function. It's a simple chain rule question. And now we're going to integrate, and we're going to use this to integrate. So here's another method, which some people use and some people don't, and I'm going to give you a couple of little look-ins that will help you. So see we've got this x, e to the 7x squared, etc. What I'm going to do is I'm going to recognise that dy dx is equal to 14x e to the x squared, and I'm now going to integrate both sides. So I'll just pop that on in yellow here. Integrate and integrate. Integration is just a thing you do. As long as I do it to both sides, that's fine. And I'm going to integrate both sides with respect to x. So I'll put a little dx there, and this has been a little tiny dx. And of course they cancel out there. I'm left with the integral of something, which is, in this case there's nothing there, so it's 1. The integral of 1 to y is just y. On this side I get y is equal to the integral of 14x e to the 7x squared dx. Okay, now this is y, but y was equal to that thing there. So my final line here is I've got e to the 7x squared is equal to the integral of 14x e to the 7x squared dx. And what I might do is I might just change this. So I'm going to rub this 14 out and just let's imagine we divide it by 14. And I'm doing it a little bit cheat way here by doing it in one line, but I'm a bit worried I might run out of space below. So I've actually divided through by 14 and I'll get this. It cleans this function up. I've got the integral of x e to the 7x squared dx. Now once I've done that, all I've done is I've done my derivative and then I've just cycled this back into an integration question. Okay, and this, if you don't quite get this process, there are other ways to do it, but this is a really nice way to do it, and then I've simplified this as much as I possibly can. Because when I move across to here, I can see that this thing is really close to that thing. Just got this pesky 12, so what I'm going to do is I'm going to say, well, this is equal to 12 times the integral of x e to the 7x squared dx. But we know that the integral of x e to the 7x squared dx is equal to this thing. So I can say, well, therefore this must be 12 times 1 over 14 e to the 7x squared. And I don't need the dx anymore, so over that, but I do need a plus c because I've now done the integral. And so I've got that with a plus c, and 12 over 14 is the same as 6 over 7, 6 sevenths e to the 7x squared plus c. You can do it this way, you can do it the way we did in the first example. They're pretty similar, it's just a different approach a little bit. It doesn't really matter too much how you do it. What it is important to recognise though is that most questions you'll be given something to derive and then you'll be given something to integrate. This will relate directly to that. You should find the only thing that actually is tricky and differs is just getting this number out the front right. The rest of it pretty much falls into place as long as you follow the process appropriately.